Hey everybody, welcome to lesson 4, sum and difference formulas. You're going to need these, so if you want to pause the video and copy these down, you can. Or you can go on the website and print out the helpful trig formulas worksheet. They have them right here. Okay, you're also going to need a unit circle, so find yourself a unit circle either on Google or a copy of one from your notes or something. But take care of all that stuff right now. Alright, hopefully you just wrote those down or found them somewhere and you got a unit circle because you need them. I'm going to leave those up still so you can see them. How these problems are helpful, these formulas rather, are helpful, is because you notice that we have sine of 15. And so far everything we've worked with has been on the unit circle. But 15 degrees doesn't show up on the unit circle, right? It goes to 30. It doesn't do 15. What we're going to find, though, is in a lot of cases we can use these formulas and we can work with stuff in the unit circle and end up getting the numbers that we're looking for. What do I mean? Something like this. 45 minus 30, that gives us 15. And we have a formula for that right here, right? One angle subtracted by another angle, and it gives us stuff to work with. So that's how these formulas, why they're so useful. So let's do this example out. We just said that 15 is going to be the result of 45 minus 30. Now the formula that we have up here, it gives us a lot of stuff, right? If we think of this as u and v, we have sine of 45 times cosine of 30 minus cosine of 45 sine of 30. So we need that unit circle, right? We have two different angles that we're looking at. 45 degrees, according to our unit circle, is going to give us root 2 over 2 for both x and y, which is cosine and sine respectively. And 30 degrees is going to give us root 3 over 2 and 1/2 for cosine and sine. So what I'm going to do now is just replace each of these with their coordinate values. Sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. This is just multiplication happening here. Cosine of 45 is root 2 over 2, and sine of 30 is 1/2. Again, we have multiplication. So here, I just multiply the stuff on the inside of the radicals together, and the bottoms are going to multiply to become 4. On top, 1 times anything, so that's not going to change. 4 on bottom. The 4's on bottom's a good thing, because now I can actually combine these, right? Simplify a little bit further. Here's what our final solution, by the way, will look like. Root 6 minus 2 on top, and 4 on bottom. That is the exact value of sine of 15 degrees. Can't get any more exact than that. So, got one for you to try out. Hopefully you have those trig formulas somewhere nearby. Pause the video. You can try both of these. Pause the video and try these both out using those formulas, and resume when you're ready to check your answers. Alright. We're going to go through these ones kind of quick. Okay, cosine 105 doesn't appear, but I know that 60 degrees and 45 degrees will add to 105. So our formula says cosine of 60 times cosine of 45 minus sine of 60 times sine of 45. Again, you need to look to your unit circles, right? We have two angle measures we're working with. 45 gives us root 2 over 2 for both, and 60 gives us root 3 over, no, 1/2 rather, and root 3 over 2. Okay, just looking at the unit circle, right? So now we can start plugging in values. Cosine of 60, cosine is x, so we get 1/2. Cosine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. Sine of 45 is root 2 over 2. And now we just have to multiply, right? 1/2, I'm sorry, 1 times root 2, and these 2's become 4. Root 6 times root 3 times root 2 is root 6, all over 4, and now we can combine. Wow, I said a lot of numbers that I didn't even want to say in that problem. Anyways, hopefully you got that answer. You had another one that you were supposed to try out in that last pause break, so let's see how you did with this one. What I'm noticing is that that's a huge number, so I'm gonna have to work with some larger numbers on my coordinate, on my unit circle rather, right? What I'm thinking would be 210 and 45. That shows up on the unit circle, so does that. Our formula says sine of 210 times cosine of 45 plus cosine of 210 sine of 45. So we need to look at our unit circle, figure out what the coordinates for 210 are. 210, it gives us negative root 3 over 2 and negative 1/2. Cosine, sine. 45, we worked with this one a bunch already. It's going to give us root 2 over 2 for both. Okay. That's really tiny. I know it's kind of tough to see, but I know exactly what that says, right? Sine, which is y of 210, is negative 1/2. Cosine of 45 is root 2 over 2. Cosine is negative root 3 over 2 times sine, which is root 2 over 2. Okay, so we've got negative root 2 over 4 minus root 6 over 4, and if we combine those, here's your final answer. Negative root 2 minus root 6 all over 4. Okay, these problems really aren't that bad, right? Just got to follow those formulas and try to work with the unit circle itself. Here's a different problem, right? They give us cosine of 5 pi over 12. We're not working in degrees anymore. Now we're working in radians. These are a little bit trickier because you have to think backwards about two radian measures that will end up giving you 5 pi over 12. That's tough to do. So what I would be thinking about is some of the possible things that show up on the unit circle that would be factors of 12 in the denominator. What am I talking about? Well, let's look at the unit circle, right? We need two numbers that can multiply to 12. And what I'm noticing is on my denominators, I've got things like 3 pi over 4 and pi over 3, right? Why am I thinking about these numbers in particular? Because that and that, when I multiply 4 and 3, I get a 12. And that's something that I need. Now, how do I know that that's exactly what I'm looking for? I don't. I'm going to check and make sure. Right? If I multiply this whole thing by 3 over 3, that's 9 pi over 12. If I multiply this whole thing over by 4 over 4, that's going to be 4 pi over 12. 9 minus 4 is 5 pi over 12. So I had to check to make sure. That's really probably the most difficult part of this problem, is figuring out what to break it down into. Because now that we have it, we just follow the formulas like before. Right? Cosine is going to be cosine of 3 pi over 4 times cosine of pi over 3 plus sine of both of those as well. Okay, now we can go back to the unit circle, which we already had handy in the first place, right? Pi over 3, that gives us 1/2 and root 3 over 2. 3 pi over 4 gives us negative root 2 over 2 and positive root 2 over 2. So now we have everything we need. We just have to start plugging in, right? Cosine of 3 over pi over 4 would be negative root 2 over 2. Cosine of pi over 3 is 1/2. Sine is going to be root 2 over 2, and sine over here is root 3 over 2. Right, and then we just got to do our quick multiplication. Negative square root of 2 over 4 plus square root of 6 over 4. Your final answer, negative root 2 plus root 6 all over 4. Okay, so just because it had a radian measure in there, made it a little bit more difficult. So you have one of your own to think about. I tried to give you one that was a little bit easier to think of what works. So try this one out and see how you do. All right. What I'm thinking is that they're giving me 5 pi over 6, which is really close to 1 pi over 6, right? It's kind of in the same ballpark, because that's what's missing is pi over 6. So why am I saying all that? Because if I had 6 pi over 6 and I subtracted pi over 6, this shows up on the unit circle. And this is really just 1 pi. But if I set it up that way, I would have seen that 6 minus 1 was the 5 that we were looking for. Right? So hopefully you figured out that you needed pi and pi over 6 as your two angle measures. Anyways, so we're going to use the formula with these values, right? We want sine of pi times cosine of pi over 6 minus sine of pi over 6 times cosine of pi. For each of these, we just got to look at the unit circle, right? Where pi is going to be negative 1 and 0. Pi over 6, we end up getting root 3 over 2 and 1/2. And now we can start plugging in, right? Substituting. 0 for sine here, root 3 over 2 for cosine. Let's see, 1/2 for sine, and negative 1 for cosine. 0 times anything that eliminates, negative times negative, those are going to eliminate as well, and we get 1/2 for our solution. That was also one that appeared on the unit circle itself, so you could have checked your work and seen that 5 pi over 6 was there as 1/2. Alright, different type of problem. Still working with those formulas though. Okay, what they're asking us to do here is solve. And as they are right now, it's not anything that we can solve because there's too many pieces, right? So here's what we're going to have to do. Got to get rid of some stuff. And we're going to use the formulas for each of these, okay? Sine of x cosine of pi over 4 plus sine of pi over 4 cosine of x. Okay. Then I'm going to do the same thing with this next one. Sine of x cosine of pi over 4 minus sine of x. Oh, sorry, sine of pi over 4 cosine of x. This is all equal to 1. Now, all I did was just use the sum formula and the difference formula. And what I notice is that this thing right here and this thing right here go away. And then I have 2 of these. So we've got 2 sine x cosine of pi over 4 equals 1. Now I can keep on working with some of this stuff, right? Because cosine of pi over 4, well, pi over 4, let's see if we look at a unit circle, that's right here at root 2 over 2 and root 2 over 2. So I can still start substituting in some values here. And I notice that my 2 and my 2 here, those eliminate. Okay, well, if I want to get x by itself, oops, I lost my x a couple places, I got to divide by root 2. And we're pretty close, except that we need to rationalize. So let's multiply by root 2 over root 2. And we end up with sine of x equals root 2 over 2. Oh, okay, so now we got to look back at our unit circle and figure out where sine, which is y, is root 2 over 2. Well, looking at this, I see pi over 4 is one of them, right? That one we saw. And the other one where we get positive root 2 over 2 is 3 pi over 4. Okay, all right. Positive root 2 over 2, 3 pi over 4. So those are the two solutions. Okay, we didn't do anything crazy. We just went through using those sum and difference formulas. We noticed some stuff kind of canceled out, right? And then we substituted in values that we knew and solved, just like we've done with all the other problems so far this unit. Okay, so I want you to try this one out. You still need those sum and difference formulas nearby. Pause the video and resume when you're ready to check. This is the last question for this, so go for it. Alright, let's see how you did. Cosine sum formula, it says cosine of u cosine of v minus sine of u sine of v. Just plugging in u value, v value, right? And then we got plus sign. We got to do the difference formula. So this is basically the same thing. Cosine of x, cosine of u. This time we want to use plus. Sine of x, sine of pi over 3, all equal to 1. Alright, so something hopefully is going to go away, and this is what it looks like. That and that. cancel each other. And we're left with 2 of these things. 2 cosine x cosine of pi over 3. Alright, well, pi over 3, that we want to find the value for. Cosine is 1/2. So 2 cosine of x times 1/2. The 2 and the 1/2 cancel. And we're looking for where cosine of x equals 1. Alright, well, cosine is going to be your x value. And x is equal to 1 at 0 and 2 pi. 0 and 2 pi. Are those the 2 solutions that you got? I hope you did. That's it for that lesson. You know, really just working with some formulas. They're pretty easy formulas. The next couple that you're going to see in the next video are a little bit more difficult than those. Plus, we've been working with a lot of the same stuff, right? Solving equations with trig, same stuff, right? So, next video, we'll be working with a couple more formulas. Until then, leave any questions you have in the comment section or bring them to class. Bye!